Binomial theorem for JEE. Let's get started. 4 marks, boss, 4 marks. You want them, you'll get them. So, let's roll. Please note the order of the questions is going to be as per the difficulty level. So, everything is planned. Now, coming to the first one that we came in Mains 2013, the term independent of x in this expansion is, well, we just have to do a bit of simplification, then I have a super trick to get the answer for this. Yes, keep watching. So, what we do is, we simplify, we can write this x as x raised to power 1 by 3 whole cube and 1 raised to power 1 by 3 whole cube. Why did we do this? Just to express it as a cube plus b cube, which can be written as a plus b into a square plus b square minus ab. Okay? How does it help us? You would see your denominator is exactly the same. So this bit gets cancelled. Further, for this one, now you see I can write it as x raised to power half whole square minus 1 raised to power half whole square. I'm expressing it as a square minus b square. So this should give me x raised to power half plus 1 into x raised to power half minus 1 whole upon, if I take x raised to power half common from the denominator, we are left with x raised to power half minus 1. So this is whole raised to power 10. Now even this bit gets cancelled. Okay, so this is x raised to power 1 by 3 plus 1 minus, now if I separate these out, this is going to be 1 plus x raised to power minus half. On further simplifying, these gets cancelled and this is x raised to power 1 by 3 minus x raised to power minus half raised to power 10. That's it. We just wanted to simplify till this portion. Now the question says find the term independent of x, and I say with my magic trick, this r is first of all going to be r is 4, so it has to be the fifth term. Yes, it is this quick to get. You don't believe me? Well, check out this video by clicking at the I button, which tells you find the term independent of x in just 5 seconds. So do watch that out. So the term independent of x would be the fifth term, which will have the coefficient 10c4 because x's would get vanished. Okay, so 10c4 would be 10 into 9 into 8 into 7, and here 4 into 3 into 2 into 1. So this becomes 7 into 3, 21, 210, and bingo. C part is your answer. Please make a note. Now moving to the second question, which came in JEE Mains 2016, the question had a little error. Now the error was that in place of y square, it was mentioned x square, and somehow we did realize that number of terms in the expansion, which is given to be an even number, didn't match. Anyway, so this was one of the suggested corrections which we go by. Now the question says if the number of terms in this expansion is 28, then the sum of coefficients in the expansions is what? Now, in order to find the number of terms in any expansion which has all different variables, I again have a super shortcut to identify the same. Trust me, it doesn't even take 5 seconds to do that. Do click on the I button to get that video. I would share the entire binomial theorem short tricks with you and you can find the same. So here, this is going to be n plus 2 C2 is equal to 28. Number of terms in the expansion would be this. Okay, few people also call this as multinomial expansion. So now on simplifying, this is n plus 2 into n plus 1 by 2 is 28, which means n square plus 3n, this is plus 2, this will be 56. So minus 54 is equal to 0. Now, if you can do it mentally very well, but please don't get into middle term splitting, because I am telling you there's a super shortcut with which you would get the answer as n plus 9 into n minus 6 is equal to 0. Yes, you do not trust me? Again, go to the I button. You would find a video with the name quadratic factorization, and trust me, you can do that within few seconds. So here, obviously your n being number of terms cannot be negative, so n is supposed to be 6. Now a very simple trick. Whenever you have to find sum of coefficients in any expansion, you would take the variables to be 1. Why do we do that? Is because we are only looking at the coefficients and we are not concerned about what happens to the variable. So if it is holding for any one, it should hold for everything which is defined. Obviously you can't take x or y as 0 here. So that means the sum of coefficients would be simply 1 minus 2 plus 4 raised to power 6, which gives you 3 raised to power 6, which is going to be 729, and ta-da! That's your answer. Okay, moving to the third one. बहुत ही मासूम सा question है. JEE Mains 2017. The question says you have to find the value of this expansion. Now I'll tell you, before we begin, I'm going to make use of couple of results. Very simple. First of all, I guess we all know NC0 plus NC1 plus NC2 so on so forth till NCN is the same as 2 raised to power n. You don't believe me? You can write 2 as 1 plus 1 whole raised to power n and then expand using your binomial expansion. This is the answer. Secondly, and a very critical thing over here is, we do know that NCR is the same as NCN minus R. Okay, so that means if I am given NC0, it is the same as NCN. If I am given NC2, it is the same as NCN minus 2. So if I'm taking half of them which are the same as the other half, then that means it is the same as this expansion upon 2 if only one of the things is given. Now, what do I mean? Let's proceed with the question. So, first of all, I'm going to segregate all the terms with 21Ci. Okay, so we write this as 21C1 plus 21C2 plus 21C3 so on and so forth till 21C10 minus, here now if I take the terms of 10Ci, 10C2 plus so on and so forth till 10C10. Now we had just discussed this result. If you look at the second one, which is more easy to handle, you would see it has 10C1, 10C2 up till 10C10. What is missing is only your 10C0. So if I add this 10C0 on my own, then obviously I have to subtract the same also to balance it out. Okay, so this portion, what it becomes is, it becomes 2 raised to power n, that means this becomes 2 raised to power 10, and 10C0, we all know NC0 is always 1, we all know NC1 is always n. So NC0 is 1. So that means my second bit has become 2 raised to power 10 minus 1. Now, moving to the second one, here a lot of terms are missing. If I try to add 21C0 on my own and subtract this portion, if you realize, is only if I start with 21. So if I am targeting 2 raised to power 21, that means this expansion is going to have 22 terms, right? Now this one, if you count from 21C0 to 21C10, there are only 11 terms. Now, are these 11 the same as the remaining 11? Please realize 21C0 would be the same as 21C21. 21C1 would be the same as 21C20. Why? Because we just discussed the formula NCR is the same as NCN minus R. Same way 21C2 which I add here would be the same as 21C19. So in short, you would realize that eventually whatever is missing is actually the same as this portion, right? So I can write this as 2 raised to power 21 upon 2. Why can I write upon 2? Because only the half of it is given. It is like NC0 and only half of it is given, but the other half absolutely matches. So it becomes, the sum becomes only half of it, and 21C0 would obviously become minus 1. So now that means we are left with 2 raised to power 21 upon 2 minus 1 minus 2 raised to power 10 minus 1, right? So this becomes 2 raised to power 20 minus 2 raised to power 10, because minus 1 and plus 1, they get cancelled. And yes, this is option D. Trust me, explaining this question took longer, but then if you have the idea of this and this concept, it does not take more than 2 minutes. Please make a note. Moving to the fourth one, looks very dangerous but है बहुत simple. So it says the sum of coefficients of all the odd degree terms in the expansion of, and you would see the same expansion with the plus or minus signs difference added. Okay, so first of all, let's just do one thing. Let's expand them and see when we add. So if it is raised to power 5, obviously it will give us only 6 terms. So starting with x plus x cube minus 1 raised to power 5. So this would give us 5c0 into x raised to power 5 plus 5c1 into x raised to power 4, and this is x cube minus 1 plus 5c2 x raised to power 3 into x cube minus 1 whole square plus 5c3 x square x cube minus 1 whole cube plus 5c4 x into x cube minus 1 raised to power 4 and plus 5c5 x cube minus 1 raised to power 5. Only one expansion was difficult because you know the other one is going to alternate in its sign. So even if you don't want to write, you can skip. You know you would get the term 5c0 x raised to power 5. You would not, this will be minus 5c1, the same thing, so you need not write. Next plus 5c2 and it will be the same term repeated. So if you want to skip writing, I'm taking the whole square directly. This is what we'll be left with. Minus 5c3, again I'm not writing because when you add them it gets cancelled. Plus 5c4 and you have x, and this would be x cube minus 1 whole square and minus 5c5 and whatever is the term, right? Now since we have to add these two first of all, so that gives us twice of, and you have 5c0 x raised to power 5. Next you will have 5c2 x cube into x cube minus 1. Next you would have plus 5c4 x into x cube minus 1 whole square. That's it. That's what we had to do. Now it says the sum of coefficients of only the odd degree terms. So you please see x raised to power 5 is an odd degree term. So I'm only looking at the coefficient. It would be 5c0. Next, if I try to open this up, this would give me x raised to power 6 minus x cube. I am only interested in minus x cube because that's the odd degree term. So I will get minus 5c2 from this one. Here, please realize 5c4. Now here, please realize this is whole square. So if I try expanding it, this is x raised to power 6 plus 1 minus 2x cube. When I multiply it with x, I'm going to get x raised to power 7 plus x minus 2x raised to power 4. Not interested in this, only interested in this. But also, please realize you have 5c4 outside. So this one gives us plus 5c4. So plus 5c4 plus 5c4 from here as well. So now you know 5C0 would always give you a 1. So 5C2 would give us 5 into 4 upon 2, that gives us a 10. 5C4 is 5, 5C4 is 5. So this gives us 11 minus 10, that's a 1, into 2. So 2 is the desired answer, which is option number 2. Please note, all we've done is expanded one of them properly. The second one will actually just alternate in sign, so you need not write it again. Rather, you can simply add and take twice of whatever has the even coefficients here, because only those are getting added. And after that, select whatever are the odd degree terms in X and take their coefficients. That's your answer. Okay. Coming to 2015 JEE Mains, the question says the sum of coefficients of integral powers of X in the binomial expansion, this is what? Now, when I talk of integral powers, please note that would mean that the expression which you are given, okay, if it is, take its conjugate. By conjugate, I mean whatever is the second one, change its sign and then add them. So what we are planning to do in this question is 1 plus 2 root x raised to power 50 plus 1 minus 2 root x raised to power 50. Why are we going to add them up? Well, you would soon realize. Just to explain you don't have to do all this in the paper. The general term for this is TR plus 1, okay, which would be 50 CR 1 raised to power n minus r, that's a 1, minus 2 raised to power r and root x raised to power r. So I can get x raised to power r by 2. Now since we are looking to find the sum of coefficients of integral powers means basically the integers. You tell me x, when does it become an integer? Well, if I give any random value to r, that would become a radical, right? Something in fraction. However, in order that this becomes integral, r must be a multiple of 2. Okay, so r is an even number. Now keep this in mind. When we start expanding, you would realize why did I ask you to add. First, to begin with, 1 plus 2 root x raised to power 50. I don't have to expand for all the 51 terms, but this becomes 50c0 plus 50c1 2 root x plus 50c2 2 root x square plus 50c3 2 root x cube plus 50c4 2 root x raised to power 4. You can go on and on, but then let's just stop here. And the last one, 50c50 2 raised to power 50, and this will be square root of x raised to power 50. Alright, now when I write the ones with the negative sign, then you would realize, just like we discussed in one of the previous questions, 50c0, the next one would be minus 50c1, so I'm not writing everything, plus 50c2, this portion, minus 50c3, again I'm not writing the expression, plus 50c4, 2 root x raised to power 4, plus the last term. Now, why are we adding? Please see, this gives us twice of 50c0 plus twice of 50c2 and 2 root x. So this makes it, so this would make it 2 square into x plus 50c4 gets added because 50c3 term gets cancelled. So 50c4 2 raised to power 4 square root of x raised to power 4 makes it x square. But so you realize that when I'm adding, I am getting all the integral powers of x. If I was subtracting, I would have got 50c1 to root x. Root x is not an integral power. X raised to power half is a radical. Okay, same way, if it was 50c3, I will get x raised to power 3 by 2, again a radical. That's the logic. So whenever, just keep in mind, whenever you want the integral powers, add them. Whenever the question says non-integral powers, simply subtract them. That's the basic trick. So Same way, proceeding this way, we get 50C50 2 raised to power 50, and this would be x raised to power 25. Alright, now on this side, that means these two get added. As I discussed in one of the questions previously, the question says whenever you have to find the sum of coefficients, just give these x's as 1, because we are only looking at the coefficients basically. So putting x as 1, what happens? My left side becomes 1 plus twice of 1, so 3 raised to power 50 plus 1, and this is minus twice, so minus 1 raised to power 50, again it would only give me a 1, is equal to twice of, now whatever happens here, 50C0 plus 50C2 2 square plus 50C4 2 raised to power 4, so on, 50C50 2 raised to power 50, you need not write the right side, we are not interested in that. What we are interested in is sum of these integral powers, which is going to be, if I take 2 on the other side, 3 raised to power 50 plus 1 whole raised to power 2, and bingo, option A is the required answer. Now coming to this question, which also came in JEE Mains 2014, it says if the coefficients of x cube and x raised to power 4 in the given expansion in powers of x are both 0, then you have to find A and B. So in short, we are trying to look for what are the coefficients of x cube and x raised to power 4 in this expansion and equate them with 0. Okay, so the only difficult part is how do we get them? Once you are given this, just open this bit. So this gives us 1 minus 2x raised to power 18 plus ax into 1 minus 2x raised to power 18 plus bx square into 1 minus 2x raised to power 18. Okay, now how do I get coefficient of x cube? It's very simple. You do realize that coefficient of x cube you would get from each and every term. So I am only looking at what term gives me x cube in each of these brackets. So here you know the basic formula, that it is NCR TR plus 1, which is the general term, is NCR A raised to power n minus r b raised to power r. If we are looking at an expansion a plus b whole raised to power n. So from here, if I want this to become x cube, that means I have to take r as 3. So here it is 18c. So here it is 18c3, and here I'll get minus 2 cube. All right. Same way from here, I already have x outside. I am looking to find x square, so that when they get multiplied, I get x cube. So I'll have to take 18c2 minus 2 square plus here this one. Now square term is already outside, x is inside. So I'm only looking at x's term. Bx square is as it is, 18c1 minus 2 raised to power 1. Okay. So if I simplify, this becomes 18c3, this is minus 8 plus, so we are just not interested in this x, so I should remove it from here, and even x square, because we are only considering the coefficients. So this will be 4a18c2 and this would be minus 2b18c1. Now each of them are given to be 0. So if I say this implies it is equal to 0, let's do a bit of simplification here. Please note, since we've taken minus 18 into 2 common, this is 8. We have taken 2 common, so 4 is left. 18 comes out common, so inside we are left with 17 into 16, and 3 factorial would give you 3 into 2. So minus sign is already common, so we are left with minus from here 2a into 17 by 2, and here since minus sign is common, plus b, and this would be only b, that's it, because 18 is taken common, 2 is taken common. So that means we are left with, so that means from here we are left with 4 into 17 into 8 by 3 minus 17a plus b is 0. That's equation 1. Now same way, making use of coefficient of x raised to power 4, we'll get another equation. This time it won't be that difficult because it's only one power more than what we've already taken. So now for coefficient of x raised to power 4, you know I will get 18c4 minus 2 raised to power 4. I'm only increasing one power here, plus a into 18c3 minus 2 cube plus b 18c2 minus 2 square. So let's simplify this. This time I'm sure we can take 18 common, we can take 17 common because that's occurring in all of them. And from here I can also take 4 common. So what's left inside is 18 into 17. I'll be left with 16 into 15. This one says 4 factorial. So 4 into 3 into 2 into 1. Okay. Minus 2 raised to power 4 is 16. 4 is already out. So 4 here. Next, this would be 18 into, so a here for sure. So minus a here for sure. This 2 cube is 8. 4 is already out. So minus 2a. 18c3 means 18 into 17 already out into 16. And here I'll get 3 factorial or 3 into 2. Plus this bit 4 is already out, b 18 is already out, 17 is already out, upon 2 is 0. So if I simplify all this, so now I've got these two equations. You can simplify this bit. Please make a note because now it becomes your do it yourself question. Yes, I've discussed everything. Now all you need to do is simultaneously solve these for A and B and tell me which one is the exact answer. Please remember to add the code BT in front of your correct option. So is it BT1, BT2, BT3 or BT4? So make a note of these equations very clearly and answer in the comment section below. I am sure you guys enjoyed this video. Yes? Then make sure to give this one a big thumbs up, share it with all the people around you. Don't forget to subscribe to my channel if you haven't done that so far. By the way, it's absolutely free. Also, don't forget to check out the various playlists on the channel for full concepts and shortcut videos. And don't forget to comment in the section below as to what is the next topic you want. I would see you with a new exciting video very soon. Until then, stay mathematically inclined. Bye-bye.